Okay, welcome everyone to the Interdisciplinary Speaker Series on the Ethics of Argumentation. And today we have a special treat. We have Haixin, and she is coming to us from the Case Western Reserve University, where she's an assistant professor in the philosophy of science. And she works at the intersection between social epistemology and the philosophy of science, where she investigates how epistemic authority gets handled within the sciences. And today she's going to give us a talk about consensus and dissent in science. Please take it away, Haixin.
All right, thank you. Yeah, let me just share my screen real quick. And can everyone see? Yes, okay. Yeah, hi everybody. Thank you so much. I'm Haixin, and it's a pleasure to talk with you all today about consensus and dissent in science. So I work in an area called social epistemology of science. And so I'm going to just spend the first couple of minutes here briefly talking about what is social epistemology and why maybe argumentation theory might help some of the problems in social epistemology. So science is not just a lone scientist working by themselves, of course, and today contemporary scientific practice hinges on scientific collaborations. There are basically no single author papers anymore in science. Almost everything is co-authored. And social epistemology is the study of how people acquire, evaluate, and share knowledge together. And it examines the social processes and institutions that shape what individuals and group can come to know. And there's some repetition here in the slides, but some of the common topics in social epistemology are things like testimony, expertise, and what I'm particularly interested in are things like authorship practices, peer review, and institutional structures of science. So instead of focusing on the reasoning of individual scientists, social epistemologists examine how interactions among researchers affect the reliability and success of scientific inquiry. So for example, peer review is this institution that is now required for things to be, for the most part, for things to be published, although of course in more recent years that there has been journals in science that no longer require peer review for publication. So that's an interesting kind of evolution of the social epistemic practices of science. And those are the types of changes that I am interested in. So what is this, like, we're going to talk about consensus and dissent in science. So what is science that we're talking about? So of course there is science is the body of knowledge. Science is an institution, but also I'm thinking about the social arrangements of science. So traditionally, the literature kind of thinks about science as either the scientific community, as this sort of big group of people engaged in science together, or that as kind of can be loosely organized or more tightly organized depending on kind of who you talk to. Or you have this very individualistic picture of science that when you talk about science, you're only talking about sort of individual scientists. So for example, work on trust in science, which is really important these days. People either talk about trusting individual scientists, if individual scientists are good testifiers, that if you are wondering about vaccines, like who do you talk to? Maybe you go talk to epidemiologists. But it would be talking to a single person. Or you might be thinking about we should be trusting science as a community overall because the individuals may not be reliable. But I'm interested in this kind of like middle group, right? So what I sometimes call the missing middle, which are collaborations and scientific groups. So the scientific community is made out of individuals, but also the individuals are arranged, especially in contemporary science, into groups. So collaborations, co-authorship groups, or other kinds of collectives in science, like committees that get convened to give some kind of recommendation about vaccine schedules or about whether or not, how often people should be screening for cancer, for example. So my work in social epistemology also, since I think a lot about groups in science, I'm right now in a large physics collaboration, which is the Next Generation Event Horizon Telescope collaboration. So the Event Horizon Telescope collaboration and the Next Generation Event Telescope collaboration are sort of two co-collaborations that whose goal it is to image a black hole. And so about, I think almost like 10 years ago now, you might have recalled seeing this image of a gold ring in the news of the first image of a black hole. So that was an image taken by the Event Telescope collaboration. It was a global collaboration between dozens of radio telescopes across the world. You need coverage in both the northern and southern hemisphere. And all of these telescopes are sort of arranged together as if they're one instrument. They're a network that are looking at these black holes. And this is radio telescope. So the image is reconstructed from radio waves in this very complex way, and it requires hundreds of people to get the results. So a lot of my work is thinking about how we get knowledge from such a collaborative structure, but also what are sort of the problems that arise within collaborations. So the large scale collaborations in physics have been really well studied, and they're in a way very unique to in the sciences. In biology, for example, people are usually in these lab groups. Maybe a dozen is like the really top number, but usually you see there's lots of smaller labs that have like 6 or 8 members. You don't really see these kinds of hundreds or even thousands of people collaborating together the way that they are very common in these large scale physics projects. So I really like this book from Nora Satina that was published a long time ago in 1999, but she actually followed a high energy physics collaboration at CERN, and she argues that in particle physics, the collaboration itself increasingly becomes part of the instrument. And so the detector, the computing infrastructure, management system committees, and thousands of scientists are all integrated into a single knowledge producing apparatus. So the arrangement of people within the collaboration is in fact part of the instrument. That if the social structures of the collaboration is malfunctioning, then the collaboration can't process data, can't actually get the result. So that's kind of where I'm really interested in what's going on within these sort of middle groups in science about how they are able to produce knowledge. So here is where I would like to sort of start talking about the topic that we're actually convened here to talk about today, scientific consensus and disagreement. So I study scientific disagreement by asking what epistemic significance disagreement has and how epistemic communities and scientific groups should respond to it. So I'm thinking about disagreement as a sort of feature of scientific communities, that it's not resolved away over the course of the collaboration, that disagreements actually persist throughout the collaboration. So I'm not really interested, I'm interested not simply in whether scientists disagree, but I'm interested in what that disagreement tells us about the reliability of scientific inquiry and the underlying justification of scientific claims. So disagreement as a feature of collaboration, but also what disagreement can reveal about scientific inquiry. And there's sort of two levels in which I'm studying disagreement. So here you see on the left a paper with me and a bunch of other philosophers and social scientists that's led by Peter Vickers at the University of Durham in the UK. So this paper came out in 2024, in which we developed a surveying apparatus to sort of quickly survey scientific community. So all from people, so basically anyone who's affiliated with some kind of academic institution. And we have coverage across the world, the UK, US, also South America and Africa and Asia, although of course the European and American universities sort of dominate our sample group, just because there's just in a way there are more universities in the US and in Europe. But we have surveyed, tens of thousands of scientists, asking them a really quick survey. So that's where we're capturing sort of the kind of large scale survey data about like the structure of a scientific community, right? So we're really thinking about what individual scientists within the and getting a really large sample size of the community, and what kind of structures of sort of the distribution of scientific opinion across this large group of scientists. So that's a very different scale, right? So we're looking at the scientific community and what the distribution opinions are. But I'm also interested in sort of what distribution opinions exist within a collaboration. So, and that difference will become more salient as we move on. But since then, the Peter Vickers group, we are formed a center that's based in Durham, called C-Scope, the Center for Scientific Community Opinion Polling and Evaluation. And in that original 2024 paper, we asked, the survey question was really simple. It was, do you think that, that was sent out to the scientists, do you think that the COVID is caused by a virus? So that question itself is not very interesting. That the paper was really testing whether or not the survey instrument works, right? So it's a proof of concept that you can actually send a survey out to tens of thousands of scientists across the world, and you actually get a good response rate. Most surveys of scientists have very, very small response rates because the surveys tend to be really big and bulky and very long and time consuming. Ours is very short, only 1 or 2 questions. And since then, we've surveyed on more interesting questions. So Peter has gone on to survey about, in particular, astrobiology, about asking astrobiologists whether or not they think that there are alien life and how likely that is, for example. But when we started this work back in, the 2022, 2023, we actually got a lot of pushback from people who are looking at this work and saying, like, why do you care about scientific consensus at all? And we actually got a lot of people who are upset about the fact that we were studying scientific consensus at all. And that in itself, I thought, was revealing. So I'm going to talk a little bit about this now. So scientific consensus is really important as a kind of a as like public relations for science and science communication. For example, I think where we think about scientific consensus the most is anthropogenic climate change. That the argument that you often hear is that you should believe in anthropogenic climate change because there is a scientific consensus about it. And here are like a bunch of surveys that using all sorts of different methodologies in the last 20 years or so that kind of persistently show that there is a high degree of agreement among scientists, climate scientists in particular, about human-caused climate change. And that is, of course, a reason that you should take, as maybe a layperson or as a policymaker, to take climate change seriously and perhaps enact climate policy. And you can kind of like tell perhaps a simple story about how scientific consensus emerges in a community over time. So this is one of the most famous graphs in the history of science. It's called the Keeling curve, collected by Dr. Ralph Keeling and he started collecting this data in the late 1950s of a systematic measurement of carbon dioxide in the global atmosphere. And you'll see that over time, the concentration of CO2, and he's collecting this data in Hawaii and in Mauna Loa, and you'll see that the average CO2 increases over time. There is seasonal variation actually, so you see this like squiggly line, right? But the trend is very clear that it's going up. So the squiggly line of the CO2 variation is actually due to the fact that plants die off over in the winter. So plants bloom and they actually capture a lot of carbon in the air, and then when they die off, that's when you see the death. Okay, so the CO2 concentration in the air, and this evidence is really clear, right? So you say like a simple story that we can tell about scientific consensus is that as the evidence mounts over time, and the community will over time accept the evidence as determines that we should come to the conclusion, or that there's a very strong inference, right, that humans are the ones who are causing climate change. This consensus messaging is not only is really important, not just because it seems like there's overwhelming amounts of evidence at this point in 2026, in particular on humans cause climate change, but also that consensus messaging is very effective for PR, for science, and for so this is a paper in Nature Human Behavior from 2024 that argues that at least of the people that they studied in this, and they actually had an online survey from 27 countries, that the consensus message actually does seem to at least seem to be effective for changing the beliefs of different people across different areas of the world. But nonetheless, it seems like, at least among philosophers, but also among lots of people that we talked to since we've been doing this consensus, or like polling work, right, on the scientific community, that we shouldn't care about consensus at all, right? So here are sort of three common responses we get about why we shouldn't care about consensus. First is that science is objective. It's kind of maybe perhaps as a philosopher of science, I would say this is perhaps a naive view of science. That people would argue that for example, the mass of the electron doesn't change regardless of what scientists can or cannot agree about it, or the mass of the electron is a fact, a brute fact in the world, and it doesn't really matter what we think about it, right? That it shouldn't matter what the opinions of the scientific community is, or what scientists believe. It's consensus is social phenomenon, and why should these social processes tell us anything about objective reality, right? So the mass of the electron is not going to change regardless of who's looking at it. Another view is that scientific consensus can often lead us astray from the truth. And people often, point to these examples in the history of science that at one point there was a scientific consensus, for example, that the continents do not drift, that there is a luminiferous ether, right, ether that carried light waves, and that parents should not feed infants peanuts, for example. And that's a very recent change, right? So used to be very recent, until very recently, pediatricians recommended that parents don't introduce allergens to kids' diets, especially babies and infants. But now that advice has changed, right? That now pediatricians recommend that parents introduce peanuts in small quantities early on in an infant's diet. So the thinking here, right, is that scientists are people too, and people are susceptible to groupthink, and scientists are being swayed by the opinions of their peers, and not being objective, right? That if just because everybody else around you believes something isn't reason for you to also believe that as well, right? And then if you look in the history of science, it's the dissidents, like Galileo always gets kind of pointed to as this like hero of science who stood up against the scientific consensus. Another reason, these are kind of all like related reasons, of course, is that what we care about is evidence directly as scientists, and not what scientists think about the evidence, right? So consensus is like what we think about the evidence. It's not about the evidence itself, right? So what we care about, right, in climate science is the evidence, right? Is the fact that we can noticeably measure the rise in global CO2 in the atmosphere, and not what people think about it, right? And that's the evidence is what determines what scientists should believe, what scientific results should be. And you see these kinds of views being echoed all over the place. So here's a list that actually Peter Vickers helpfully collated together from all over the place, on people saying things like scientific truth is not established by consensus. Science is a matter of evidence, not the majority of scientists think. Scientific truth is not decided by majority vote. Of course, ask Galileo. Scientific truth is not determined by consensus. In science, the majority can be and often have been wrong. There's a great deal of peer pressure in the scientific community, which can stifle objections to a popular theory. When everyone believed that the world was flat, they were wrong. The truth is not divided by a show of hands. So I just want to highlight one of these comments, in particular by Michael Crichton, who is very famous who's a celebrated author, but also a climate denialist, right? You might know him he's a creator of the popular TV series ER, and he also wrote Jurassic Park, and he gave this speech at Caltech, actually, in which he criticizes scientific consensus, in particular in the context of denying climate change. So he says here, I regard consensus science as extremely pernicious development that ought to be stopped cold in its tracks. Historically, the claim of consensus has been the first refuge of scoundrels. It is a way to avoid debate by claiming that the matter is already settled. Whenever you hear consensus of scientists agrees on something or another, reach for your wallet because you're being had. Let's be clear, the work of science has nothing whatever with consensus. Consensus is a business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has results that are verifiable by reference to the real world. In science, consensus is relevant. What are relevant are reproducible results. The greatest scientists in history are great precisely because they broke with the consensus. There is no such thing as consensus science. If it's consensus, it isn't science. If it's science, it isn't consensus, period, right? So you see him being there's a very strong objection, right, to why consensus sort of has nothing to do with what's going on in science. Creighton, of course, has this view of this kind of like hero scientists, right, who is like kind of maybe uniquely rational, right, that stands against all these social pressures. And you kind of actually see that theme reflected in his fictional works that he's kind of famous for. So Crichton is not wrong in a way, right? Of course, he's wrong in the fact that like he's saying this kind of his argument against consensus is part of an argument against climate change, right? Believing climate change. But I would say, of course, that there is actually evidence for climate change, so we don't. But however, what I want to point out about this Crichton view, actually, which is very, very common if you have a conversation about scientific consensus, is this sort of central role that dissent has in science. And dissent is essential for science. And I actually, philosophers of science are in fact in consensus over the importance of scientific dissent and disagreement. Dissent is crucial for the advancement of science. For example, disagreement is often at the heart of peer review, that when scientists are often reading each other's work and looking at each other's work with a critical eye and giving referee reports that are critical and raise objections. Disagreements also serve this really important epistemic role in science. Disagreements can unearth unjustified assumptions, flawed methodologies, and problematic reasoning. It promotes conceptual clarification, reveal the role of background values, right? So I feel like these aren't things that, at least in this crowd where you guys study argumentation theory, this is probably very things that have already been discussed. By enabling and encouraging dissent, scientific communities create space for alternative hypotheses, models, and explanations, and thereby strengthening the critical and self-corrective character of collective inquiry in particular. Right? The social epistemic aspects of science is what makes science reliable and robust, and the best sort of source of knowledge that we have about the world is in fact that scientists are in this kind of critical stance against each other, right, is the reason why we should believe science. And that's kind of an argument that's been well tread in philosophy of science with people like Helen Longino, Naomi Oreskes, who have really use this kind of line of argument to argue about why we should trust science and why science is reliable. I also want to add that disagreement and dissent in science is not only good for the progress of science, right? Of course, like this argument here about dissent being essential for science is kind of an argument about science from the view of a historian in a sense, right? So if you're looking at science kind of zoomed out over a very long period of time, looking at the scientific community as it develops over time and gathers new evidence and respond to evidence as a group, science is kind of proceeding by this way, that having heterogeneous opinions within a community, right, will give you these kinds of good characters in scientific inquiry. But these disagreements are not only an engine, right, for scientific progress, but actually disagreement in science can be seen as second order evidence. So first order evidence consists of evidence that bears directly on a scientific claim, such things like observations, experimental results, or model outputs. So for example, if you think about a clinical trial, you're looking at like the actual data that you collected that say like, oh, well, the intervention group did better than the, at least on average or statistically, than the control group, right? So that's the direct evidence that you have, the data that you are collecting in your experiment. That's first order evidence. Second order evidence consists of evidence about how that first order evidence should be interpreted, weighted, or trusted. So if you think about the clinical trial, maybe the trial was itself poorly designed, or the researchers made a statistical error, or actually equally qualified experts interprets the data differently. So that's a kind of second order evidence. It's evidence about your evidence. So expert disagreement provides this kind of second order evidence about that underlying, that speaks to the underlying evidence. And it can actually show that the underlying evidence, the first order evidence, is difficult to assess, or that reasonable experts can draw different conclusions from it. So this, in philosophy science, we call this kind of underdetermination of theory by evidence, or any body of evidence may support more than one reasonable interpretation, and equally competent experts may actually reach different conclusions while drawing on the same underlying data. So under these conditions, the structure of expert opinion actually becomes epistemically significant, right? So that the structure of expert opinion in a large enough group will actually reveal, it's like additional evidence, right, about what we should believe. So consensus, fragmentation, polarization, and disciplinary variation are not merely sociological facts. they are themselves evidence about the state of scientific inquiry. So the fact that there is, in biology, for example, a lot of disagreement in the biology community over whether or not group selection is a real phenomenon, or if group selection can be just reduced to individual selection. That itself is evidence about the state of scientific inquiry and whether or not these views are reliable or robust. But disagreement, but you might think, despite the fact that disagreement is really important in science, shouldn't scientists aim for convergence anyways, right? So even though we think that dissent is good, isn't consensus really a goal of science, right? So we want, if in the beginning, or if you think about climate change, right, in the 50s and 60s, when we were still collecting a lot of data about the climate, trying to understand the global climate system, maybe there was disagreement about whether or not what we're seeing is actually part of a larger climate trend, or if it just is like variation, right? The globe is really big. We don't know what the scale of climate fluctuations are. So maybe it's just like, we're just like in a mini ice age or a mini hot age. I don't know actually what it's called, mini tropical age of the earth, right? And we don't, so we shouldn't, but as the evidence mounts, right, shouldn't those disagreements be resolved, right? Shouldn't the disagreement between scientists over there is climate change, or there is no climate change, right, just resolve over time? We may all think of like consensus or coming to agreement between a group of inquirers as a natural closure of arguments. And of course, it seems like consensus, at least scientists really want to project consensus. Like scientific papers are written as if the collaboration or the group of the co-authors, a group of co-authors, they're speaking with one voice, right? You don't really get, when you read a scientific paper, even one that's authored by hundreds or even thousands of scientists, they're not saying like, oh, well, like 25% of us believe this, and then we have a disagreement about this, right? Like that doesn't show up in the scientific paper. The paper is written with one narrative, with one voice, with one sort of consensus statement in a way. But of course, with any given group of researchers, there will be a range of judgments and opinions. People are cognitively diverse. Even though we'll see this consensus statement, right, the actual what individual scientists believe about the paper might actually be, there'll be a variation, right? So at the community level, philosophers of science have mostly studied disagreement in science as a good thing. It's a positive thing. People like Helen Longino, Naomi Oreskes, etc., they really believe that science, we should preserve, actually maybe even encourage disagreement in science at the community level, because of this idea that disagreement is the engine of scientific progress. But at the level of collaborations, right, at these level of people writing a paper together to get published, too much consensus can produce groupthink, conformity pressures, and premature closure of findings. But too much disagreement can produce fragmentation, inability to coordinate, and failure to make decisions. So the challenge at the collaboration level, right, at the mid-group level that I'm looking at, right, is finding the right balance between consensus and disagreement. So let me just go back to my chart here, right? So the idea here, right, is that at the community level, we want there to be lots of heterogeneity, right? According to philosophers of science here, right, that the scientific community is really healthy when there is lots of disagreement, people who occupy diverse perspectives, who are committed to have different methodological commitments, different background theories, making up your scientific community, so that you can, really reap the rewards, right, of having constant disagreements across members of the scientific community. Yet at the collaborations level, the scientific group level, right, at the actual like authoring units of science, right? People writing co-authors papers together, which are the outputs of science that we actually see. At that level of organization, there's actually a lot of pressure for consensus, right? That too much disagreement within a collaboration is going to make the collaboration fall apart. If you have for example, in high energy physics, right? If you have people who really believe different things or believe different, who think that the instrument's unreliable. So in LIGO, which is the big gravitational wave detector, which uses like a laser, and that laser, it's really, 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 really sensitive. And there were disagreement within the collaboration about whether or not their instrument is reliable. And if there's too much disagreement about whether or not your instrument is reliable, that collaboration is going to fall apart and fragment, right? And people are unhappy in a collaboration, or they don't want to coordinate with the collaborators, right? Then the collaboration is going to fall apart. So for the rest of this talk, I'm running a little low on time, but I think I can get this. Okay. So at the collaboration level, you really see the push and pull of consensus and disagreement. So I'm going to say more about this. So I call these kinds of disagreements intra-collaboration disagreements. So these are disagreements that arise out of the course of scientific inquiry within a collaborative group, right? Within your co-authoring group. So those of you who have co-authored, right? It's like kind of becoming more common these days in philosophy and parts of the social science, of the humanities. But people, although the co-authoring groups in philosophy tend to be quite small, like usually like 2 to 3 people. You rarely see anything above 3. But like in the course of co-authoring a paper with people, right? You are always going to be trying to resolve disagreements, right? You're kind of debating with your co-author over like what to include, how strong the language should be, all those kinds of things, right? And researchers in these kind of intra-collaboration settings, right, can disagree over a whole range of things. Things like the science, right? So what I would call maybe first order evidence, right? Interpretations of data, methodological choices with the strength of evidence, right? So the scientists will call this like, we're disagreeing about the science, right? They'll say something about like, we're disagreeing about the actual evidence. But there's also disagreements over just like practical things, like differing expectations over timelines, responsibilities, disputes over ownership of research products like publication and data. Authorship and credit is a huge source of disagreement within scientific collaborations, like if people should be first author or a last author, right? Who people are jockeying for positions on the author list. And when results should be released publicly, right? Often scientists, you'll get a group of scientists where people who are very conservative about releasing results publicly, and then people who are more liberal, who are just like, oh, we should just publish as soon as we have enough data. And then people will say, other people in the collaboration will be, no, we should only publish when we go through all these different checks and really do a lot of work, right, to validate the data before we publish. So these are all different kinds of disagreements. And there are many sources of disagreement in collaborations. There are, of course, these usual suspects like cognitive diversity, personality clashes. But the thing that I really want to focus on is this idea of misaligned incentives. So inherent to really big teams in science are this push and pull between collective achievement and individual achievement. So collaborations reward collective achievement, right? So in that ring of the event Horizon Telescope took of the black hole, right? That's an achievement of the collaboration with like hundreds of members in it. However, individual scientists within the collaborations, their careers depend on being individually successful, right? Universities are not hiring a collective, right? They're not hiring a collaboration. They're hiring individual scientists, right? People get promoted and get raises, right, on individuals. The Nobel Prize, for example, except for the Nobel Peace Prize, all the other Nobel Prizes can only be split, I think, a maximum of 3 or 4 ways. So you're always kind of isolating individuals, right, even in these collective achievements. So we have this difficulty in large groups to incentivize public goods, like service work to the collaboration, like software, calibration, governance, mentoring of graduate students and postdocs, and those kinds of service work that feeds the public good of the collaboration, we typically receive less recognition than getting sort of high profile scientific results. And while the collaboration seeks a coherent public voice, individual scientists often value intellectual independence, right? So you have this kind of really interesting misaligned incentives within the collaboration where the collaboration itself wants to be a collective, but the individuals want to have independence. And you see this show up in all sorts of ways, right? Individuals and institutions operate on different timelines. These these large-scale collaborations in physics have the timelines of decades, right? These high-energy physics collaborations have been working since the 90s, right? And individuals, right, the postdocs need a publication next year, right, because they're on the job market, right? So you can kind of see there's this kind of misaligned timelines. Scarce resources create competing interests within a collaboration. There's always not enough money in science, right? Especially these big, large, resource-intensive collaborations, where people are always fighting for instrument time, for telescope time, and for money, of course. There's people who argue, have different views about publishing quickly versus publishing reliably, which typically is slower. Competition within the collaboration for leadership positions, speaking roles, etc. And making matters worse, scientists are rarely accountable only to the collaboration, right? So scientists are accountable to their home institutions, to their labs, to their PI, and those things might actually not be the collaboration that they're in. So managing these kinds of disagreements that arise inside of a collaboration ends up being really, really difficult and very fraught, because there are not just disagreements over epistemic things, right? But where you can maybe those types of disagreements can be resolved, or you could come to some kind of compromise about. But actually, many of the disagreements in large collaborations, when you have a group of people trying to work together, arise from competing incentives rather than competing interpretations of evidence. And they cannot be settled simply by collecting more data. So resolving such disagreements require procedures for making collective decisions, allocating authority, and determining what counts as fair and legitimate outcomes. So questions of collaboration governance, therefore, become central to the management of disagreement within a collaboration, right? So disagreements have this ability to become very corrosive, right? So, there's lots of collaborations that collapse because the disagreements among co-authors become so toxic that they dissolve, right? These collaborations dissolve where they fail. So pulling together all these people to work on these big problems, right, require getting the disagreements to in a place where you get that it's fruitful, you get productive disagreement and not pathological disagreement. So, and a lot of these disagreements, because they arise out of these kind of misaligned incentives inside the collaboration, they end up needing to be resolved in a way that over governance issues, right, about authority. So things like who has the authority to decide. Is it the PIs or the project scientists? Is it the executive committee? How should competing interests be represented? What procedures are perceived as fair, right? So for people to accept the decision that gets made, like we're going to publish quickly rather than publish slowly. Who was that decision made in a fair way, right? and what makes a collective decision legitimate in the eyes of those who must abide by it. So you might be tempted to say that what we should do is actually just align incentives, right? So if I'm saying that these problems arise because of misaligned incentives, shouldn't we just align incentives, and that way we get rid of a lot of these problems? And to an extent, misaligned incentives are structural to large groups. So I don't think they can be kind of like swept away or designed away. But the tension between individual and group incentives can often be productive. The results can be better if the members are in a little bit of competition, right? That's why there is disagreements good, right? That you have friction inside of a collaboration, it actually could bring about more and better results. So my suggestion is that collaborations should align incentives when possible, but for the majority of cases, recognizing how incentives are misaligned is more important. And that's where transparency about decision-making is actually going to be the most important, right? So we'll have to ask questions about authority, about who decides, representation, about whose interests are included, and legitimacy, right? Why should members accept those kinds of decisions? So disagreements cannot be resolved, especially in these like closed groups, right? By determining who's correct, but instead, we need to think about procedural fairness within a group, right? Was the decision reached through a fair and legitimate process? Different parties possess different forms of authority, and the goal is not necessarily to agree on every issue, but on a decision that appropriately incorporates different values and goals. And the challenge is determining whose authority should prevail in particular circumstances. And the role of the executive committee, which are these large collaborations are typically governed by an executive committee, their goal is often to create processes that participants regard as fair and trustworthy and not coming to the correct decision, right? So changing the goal of deliberation in these collaborations to agreement with a decision versus acceptance of a decision as legitimate. And the latter is often more realistic. And this is actually the viewpoint that's like in bioethics, right? So when you have these like disagreements in treatment groups, right, of between the patient, the patient's family, and the care team, right? So in bioethics, people kind of talk about making decisions this way often. Well, it's about the procedure and the legitimacy of the decision rather than coming to the correct decision. So in the last like 2 minutes here, I'm just going to talk about argumentation theory, right? Because I haven't really thought about argumentation theory until I got the invitation to talk with you guys, which is great. I'm kind of soliciting advice from you guys. So I started thinking about this, and it seems like that, it's always like philosophers of science have a lot to learn from argumentation theory. Philosophers of science have mostly treated disagreements primarily as an epistemic phenomenon. And bioethics, right, this biomedical perspective that I was talking about, treat disagreement as a governance phenomenon, right? It's a problem of legitimacy and authority. But it seems like argumentation theory is treated as a dialectical phenomenon. But in large scientific collaborations, we kind of require all three perspectives simultaneously. We need to think about the evidence. We also need to think about the authority and governance, but also have the competing viewpoints been adequately aired and critically assessed, right? Having this kind of dialectical fairness. Classical argumentation theory often assumes that disagreement is resolved through better arguments, but often in science, arguments alone do not settle disputes. Rather, it's the institutions that do, especially in these kind of large collaborations. So I think there's lots of space for there to be a gap to be filled by argumentation theory, which is that much of philosophical disagreement literature, the philosophical disagreement literature assumes the goal is to determine what one ought to believe, right? So this is like couched in a lot of epistemic terms. But scientific groups often face a very different problem, is that how should a group decide what to do when the evidence remains uncertain and reasonable disagreements persist? And the evidence, even though sometimes it could really, there is like crucial experiments, there are evidence that actually just close debates. but sometimes evidence remain uncertain, right? So for long, you have lots of examples of this, like long COVID, for example. What is the evidence for long COVID? Like, what is it a stable phenomenon? Like, what causes it, right? All those kinds of things. There's lots of uncertainty about this, and there was lots of disagreement about long COVID, for example, that continue to persist today. The insight from argumentation theory, I think, is that deliberation is different from demonstration, right? So the problem is that, in when we talk about what we ought to believe, especially among epistemologists, is that we want to try to establish that a proposition is true. But in a deliberation, participants weigh competing reasons in order to choose among possible actions. And deliberation is about reasons, but not certainty, right? So so aiming for certainty perhaps is the wrong thing to do. And this is the thing that I think is really important, is that scientific deliberations rarely involves only epistemic reasons, even though people will sometimes talk as if it involves only epistemic reasons, but that's not true, right? And argumentation theory can help us see the full scope of reasons, like prudential reasons, methodological reasons, ethical reasons, etc. Right? So, and all those things enter a scientific deliberation for a scientific collaboration, in fact, to engage in successful collective inquiry. Okay, so that's the end. Thank you so much, and I look forward to your questions and comments.